I thought it might be helpful for me to go through an explanation of the answers that I posted on the website. So here they are. And I left my pen at school that I usually use to do this kind of thing, so I'm just going to kind of explain it and make a few notes here and there. It's a little more awkward since I don't have the pen. So which is a substance? You might want to write on your cheat sheet that a substance has one identity. So I'm going to put ID for identity, so that's easier. But the saltwater solution has both salt and water in it, so that would be two different things. And the element iron only has one identity. It's just an element, one kind of atom. So the answer is B. Now a substance, what did we just say a substance was? It's something with one ID. So all the atoms are alike. If you look at these three choices, you can see that sodium and oxygen are different elements, so they don't have atoms that are alike. And hydrogen is the same thing, H and H, so those atoms are alike. And Na and Cl are different elements, so the answer would be B. So you might want to remind yourself that elements contain one kind of atoms, and compounds contain two kinds. So element, you'd say, it's difficult to write here, but elements, one kind of atom. And compounds have two kinds of atoms, or more. Sometimes they have more than two. A substance in which exact combinations of the elements are always the same might be something like H2O. We know that water always has two hydrogens and one oxygen. What do we call that? That's a compound. If it's diatomic, now diatomic, what's di mean? Di means two. So if it's a substance, it's one kind of, it's either an element or a compound, but since nitrogen, so it's N, so it has two of the same kind of atoms. So that would be N2. So you might want to remind yourself that diatomic means two elements. And once again, substances have one identity. They are either elements or compounds. Now, I realize I'm talking kind of fast, but if you need to hear it again, you just stop and rewind. Okay, solutions are evenly mixed, so even mix, but they are a mixture. So if they're a mixture, they have two different identities. So here we've got chlorine, that's an element. We've got fog, which is a mixture. We've got salt water, which is a mixture. And we've got sand, which is mixed with water, so that's a mixture too. But you see, fog is not completely evenly mixed. If you remember talking about colloids, you remember we mentioned that you could, and I showed you a laser beam going through some liquids, that if light is scattered, it's not a complete solution. And fog, you know, from your experience, scatters light. So the only thing that's evenly mixed, completely evenly mixed here, would be salt water. So your answer is C, salt water. You might want to make a note that a solution is a completely even mixture. Right? Number 6, if you can separate a sample of matter without a chemical reaction, then the atoms were not bonded together, at least not with a chemical bond. So we would say that the matter was a mixture because we didn't have to do a chemical reaction to separate it. So that would be one of the first things we did. In the first lab we did was with evaporating the water. Excuse me, the salt water, and left the salt behind, or we used a magnet to pull out the iron. You may remember that. We used a filter paper to filter out the poppy seeds. So if you can separate something without a chemical reaction, it was a mixture. If a chemical reaction is required, then the substance would have been a compound. Then we move to this section. There were lots of different answers for some of these and only one for others. So I'm going to flip back and forth and explain the answers. Elements have only one kind of atom. So if you look right here, this is only one kind of atom. This is only one kind of atom. This is only one kind of atom. Box G is, you could also make an argument that that would be a correct answer because it's a mixture of elements, but still there are only elements in this box. That's an element, that's an element. These are the same kind of atom, that's an element. For letter number 8, heterogeneous mixture of elements and compounds, there's only one answer there, and that would be, remember, heterogeneous means uneven. You know, all these things I'm saying you might want to put on your cheat sheet. So you've got a mixture of elements and compounds right here. See, element, compound, compound, element. Okay. Only compounds, there are lots of answers to that one. So this contains elements and compounds, this contains elements, this is compounds only. See, they're all the same, there's 5 molecules. Same thing here, compounds only, oh, take it back, this is an element, so that's not a compound. This one, and the reason this is an element, because they're the same kind of atom. This is a compound, because these are all different or same kind of molecule, but they have different kinds of atoms attached. And this one is a mixture of compounds, but still you could make an argument that this answer was correct because that's a compound and that's a different compound, but they're both compounds. A mixture, mixtures have multiple identities. So that's a mixture, and that's a mixture. The others are not mixtures. A pure substance is anything with one identity. So that could be an element or it could be a compound. That one works. That's not pure. That one is pure. That one's pure. So is that one. So is that one. But this has multiple identities. That one's pure. And this one has multiple identities. 5 molecules. 5 molecules would be this one, because 1, 2, 3, 4, 5. Nothing up here. This one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That one works. 1, 2, 3, 4, 5, that one works, and 1, 2, 3, 4, 5, that one works. Notice it just says 5 molecules. It doesn't say whether they're mixtures or compounds, or if they're pure or not. So it doesn't say if they're pure or compounds or mixtures. It just says has 5 molecules. So all those choices that I wrote down would work. Now when you get to this part of the test, I'd suggest that you put in your cheat sheet that protons plus neutrons equals mass. And I would suggest that you know that protons equals electrons unless there's a charge. Write this here. This is also going to be relevant later on in the test. All right, unless there's a charge. It's hard to write with my finger and a mouse pad. All right, so here we go. Number of nucleons in carbon-14. By the way, you want to know that this is mass, this number here. When you see a name of an element followed by a number, that number is the mass. This number will disagree with what the periodic table says because I'm giving you an isotope that's not the most common isotope. So you need to know that the periodic table is only definite for the number of protons. That one can't change. Number of protons always has to be the same. But the number of neutrons can change, and therefore the mass can change. All right, so protons and neutrons for carbon-14. Protons and neutrons make the mass, so there would be 14 protons and neutrons total. But the number of protons would be the atomic number, so that's 6. And the number of neutrons would be, remember, protons plus neutrons equals mass, so if the mass is 14 and the number of protons is 6, then the neutrons have to be 8, because 6 plus something has to equal 14, so the answer is 8. The smallest unique unit of an element would be the atom. So atoms, if you divide an element down into the simplest piece you could possibly get of that particular element, like what's the simplest piece of copper or what's the simplest piece of gold, you would call that an atom. Electrons and protons and neutrons are simpler, but they're not unique. An electron in copper is the same kind of particle as an electron in gold, so they're not unique. Atoms are unique. What gives the nucleus a charge? Remember, there are 2 things in the nucleus. They are protons and neutrons, but only the protons have a charge. So the answer is C. Isotopes, they have different numbers of neutrons. That gives them a different weight. So the answer is D, neutrons and mass. The electron, in an atom, remember you got a little nucleus here in the middle, and you got this, the electrons around the nucleus. There's lots of empty space out here. All of the mass is in the nucleus. So we would say the electron cloud, that's this area out here, is negative and it's very low in density. the mass of the atoms in a pinpoint. I just told you that was true. That's where the nucleus is. And all atoms of the same element, they got to have the same atomic number. They have to have the same number of protons. Atomic number is number of protons. You might want to put that on your cheat sheet, that atomic number equals protons. Missed my pen. Atomic number this is supposed to be an A in case you can't read that. Atomic number equals protons. So you might want to know that. Okay, so the subatomic particles that are not in the nucleus, okay, so would be the subatomic particles that are not in the nucleus, that'd be the electrons. So you have to put the actual name down here. The mass of the atom is in the nucleus. What subatomic particles determine the mass? That would be the protons and the neutrons together. The subatomic particles you expect to find in energy levels outside the nucleus, that'd be electrons. And the subatomic particles in the center, that's what's in the nucleus. That'd be the protons and neutrons again. So you see I'm just asking the same thing in different ways to make sure that we have a good understanding. And then the subatomic particles that are most involved in bonding, those are on the outside. So that'd be the electrons. Now computing this chart, once again you need to know these concepts right here. I don't know if I could do, I can't. So these things right here, you might want to put down on your cheat sheet. I don't know if I could copy that. No, I can't. I was going to circle it and cut and paste it, but I can't do that. So go back over here. Wow. All right, so now I've got something going on I don't know how to get out of. All right, so I'll call this part 1 of the video and stop recording right here and come back and do it again in a minute.